I'm taking the same problem I just had, but I'm putting a negative sign in the middle instead of a plus sign. And what I'm going to tell you is we get a different shape, although they're very related. Okay? That's called a hyperbola. And by the way, I should probably give you the definition of a hyperbola. All right? But in order to do that, the easiest way to do it is to take a look, revisit the definition of an ellipse. Do you remember what the definition of an ellipse is? Set of all points in a plane such that the sum of the distances, where's it at? I got it here somewhere, guys. You do too, right? The sum of the distances from two given points is constant. All right? Check this out. I'm going to modify our definition so I can call it hyperbola. A hyperbola, see that thing some? I'm going to change that to difference. Then I'm done. Same definition. That's kind of weird. So it's the same definition. Now, by the way, you notice I didn't ask for 2 volunteers today with a string, did I? It was easy for me to represent the sum of the two distances being constant. I had that fixed string length. It is not so easy for me to represent the difference being constant. And I will show you what I know about that with an example. Okay? And this is in the book. I'm going to move on. Boom. Back to our example. Okay, so that's an equation of something called a hyperbola. Question is, how do I graph it? Okay? The answer is a lot like the ellipse I just graphed. Start with this. Whoa, that took a lot of work, remember? So let me start with that. Again, the first point I plotted was what? The center. So I plotted 3, 1. Okay. What are the next 4 points I plotted? Yeah, I used A and B, that's right. So remember, A was 5. And B was 3. And that allowed me to move out 5 in each direction and up and down 3. But now here's what I'm going to do, guys. Instead of plotting an ellipse again, I'm going to draw a rectangle. I'm going to draw a rectangle. A rectangle that goes out that far. In other words, if I were to draw the ellipse again, it would be contained in and tangent to this rectangle on 4 sides. You could say that the rectangle circumscribes the ellipse I would draw. Does that make sense to you guys? Okay. But this is not an ellipse. We're drawing something called a hyperbola. One of the features of a hyperbola, okay, this is a curve with asymptotes. Do you guys remember what those are? Thanks, guys. Well, it's not the final exam week yet, right? And by the way, the glorious review for the final exam is yet to come, okay? And we're going to kind of review all this stuff. But let me just remind you of one of my favorite curves that has an asymptote or two. How about this one, guys? Y equals 1 over x. Can you just tell me where an asymptote is for that one? What's that? What zero? You're right. Are you thinking of this vertical asymptote at x equals 0? Or were you thinking of the horizontal asymptote at y equals 0? You guys remember this? Well, because what happens when you put in a really big number like 1,000 for x? You get really close to 0. But what happens when you put in 0? Well, then the thing gets really big, right? Or really small if you put in a negative number. I don't know if I told you guys this, but this is actually a hyperbola. But it's not the kind I'm going to be drawing now. I'm going to be drawing one with this equation. Okay? And what I said you do is, first you pretend you were drawing the ellipse. Draw the rectangles. Okay. What the rectangle does for me is it allows me to find my asymptotes. Basically, if you draw the diagonals of this rectangle, those are the asymptotes. Okay? So, for example, it'll also go through the center, by the way. See that? Because the diagonals of a rectangle must bisect each other at the center. So there's that. And then there's this one. There's my asymptotes. And now, I want to think for a minute about where I would find solutions to this equation. X minus 3 squared over 25 minus y minus 1 squared over 9 equals 1. By the way, this is pretty challenging to find actual points that work. The one hint I'll give you is this. If you deal with the fraction that's positive, it's a little bit easier. Because, notice, that's the one with the x's, right? What I'm going to suggest we do is go out here to this point right here. That's the point. What point is that, guys? Well, something comma 1, yeah. 8, 1. That's right. 8, 1. And if I were to plug in 8, 1 into this equation, let's check what happens. 8, comma 1. If I plug that in, I get 8 minus 3 squared over 25 minus, what happens here? 0. Do you see that? Okay. Equals whatever it equals. Well, let's see. 8 minus 3 is, do you see that this is going to work? Well, okay, let me explain that a little better. Because what I have to plug in is the 1, right? So I'm going to get 1 minus 1 squared over 9. So it really does equal 0. Does that make sense to you guys? That's the easy solution. Oh, there's one other easy solution. See, you don't have to just get a 5. If you get a negative 5 and square it, that also works. So you could try this. You could try plugging in, what point is this? I guess that would be negative 2 comma 1. And then I would get, if I try negative 2 comma 1, I get negative 2 minus 3 squared over 25 minus 0. And that's negative 5 squared over 25 minus 0. And that equals 1 also. Okay, so far, how many points do I have? 2. There's infinitely many solutions. Let me tell you what the rest of them look like. This is an asymptote. That means that the curve gets closer and closer and closer to the asymptote without ever actually hitting it. Closer and closer and closer to the asymptote without ever actually hitting it. here's a pretty good sketch of all the points. That would be the solution for that equation. Okay? Now, one other thing to do, and that is to find the foci. I want to find the foci. Okay? Well, to find the foci, I need to know that c squared equals a squared. What do you think it's going to be? For the ellipse, it was the difference of a squared and b squared, but I had to put them in the right order. Guess what it's going to be? Hooray! I remember that one because that's the Pythagorean theorem too. You guys with me? So I'm happy again. Foci are easy. So let's see, what's it going to be for this case? C squared is going to be, what's it going to be? Well, 25 plus 9, right? That's my a squared and b squared. So c squared is 34. So c is, what do you get? Well, the square root of 34, right? Which is a little less than what? Yeah, the square root of 36, which is 6. Is this okay? It's a little less than 6? If it's okay with you, it's okay with me. All right, so we're going to come over here. Now, the foci will be located, let me draw them for you. I start at the center. I'm going to go out past this vertex. How far have I gone so far? A was 5, right? So I've gone 5. I got to go out a little more, a little less than 6. There it is. I guess that would be the point, if you really want to know. 3 plus the square root of 34, comma, 1. I don't know. Cameron said he really wanted to know. This one over here, I go out not quite 6. What's this one going to be, guys? Now I want to know. What's this focus going to be? 3 minus the square root of 34, comma, 1. Okay? Those are the foci. And what I am saying is that if you took some point on the hyperbola and you measured the distances to those two green points and you subtract, you always get the same thing. Really? Yeah, really. Matter of fact, let me call one of these foci, let me call this one here point F. Okay? Well, I'll call that F number 2, and I'll call this one F1. And what I'm saying is for example, the distance from F2 to 8,1 is that a big distance or a small distance? That's pretty small, right? It's right there. You guys with me? If I subtract that from the distance from F1 to 8,1, I get some constant. By the way, do you see what I would get? That's this distance here. If I take the distance from F1 to 8,1 and I subtract the distance from F2 to 8,1, do you know what I would get? I'm going to get 2a in this example. Because it's like, do you see that there's some symmetry? This little piece, this little red piece, is the same as what's over here. You guys with me? And a was 5, so I guess in my example I'm actually going to get 10. But what a hyperbola is, and this is hard to see, if you pick some other point up here, measure this distance and measure that distance, and subtract those lines, you know what I'm going to get? 10. This guy minus that guy is 10. It's always a difference of 10. And this is the shape you get. Well, it's hard for me to say too much more than I did. Like, I guess you ask a great question, though. Why should I get an asymptote? Okay? Let me explain it this way. I want the difference to always be 10. All right? So let's see. Jim and I are how far apart right now? We're too far apart. Oh, no, we're not. That actually might work. Well, not quite. I got to be, a little farther than 10 feet. Wait, hey, how far are Jim and I apart? Jim, raise your hand so everyone knows who you are. All right. How many feet? 20 feet? Okay. Let's make sure that everybody on the hyperbola is at least 20 feet away when you subtract, right? So notice Jack here might qualify to be on our hyperbola. Jim and I are the foci. Jack is 2 feet from me. If you're 2 feet from me and 18 from... No, that wouldn't work. Well, let's do it this way. Let's suppose that we're actually 22 feet apart, Jim and I. Anyone going to argue? Thanks. So, if we're 22 feet apart, and you're... Yeah, then I guess you're 18, right? All right, that didn't quite work. I'm trying. What I'm... Back to the picture. Do you see that this red distance and that distance are 10 apart? Okay. Let's look way up there, because remember, an asymptote says what happens when you go to infinity. All right? Now, again, F2, that's me, F1, that's Jim. How far is Jim from the sun? How far? 93 million miles or something like that? Right? Okay. How far am I from the sun? Well, 93 million miles plus an extra 10 feet. See, because he's closer because he's east. Are you guys with me on this? Now, I don't care if we're going to the sun or we're going to the halfway to the sun. Those lines we measure are going to be pretty close to each other. So when you get out there, you can imagine that the path is going to make an asymptote as we move towards the sun. Maybe. That's the best I can do, Barb. I can do one more thing to help you understand a hyperbola. This is actually really cool. A hyperbola is sometimes called the dual of an ellipse, or it's an ellipse turned inside out. Here's what I mean by that. You guys know for an ellipse the foci are inside the curve, right? Well, I claim the foci are still inside the curve. It's just that you have to imagine that what happens is, like when you go this way to infinity, infinity is like a point where it closes up and you come back over here or something like that. So you guys grew up playing video games, but you didn't play what I played. I played Atari. How many have ever heard of Atari? Oh, yeah. Pac-Man. Don't you get it? Right? Or you guys have played Miss Pac-Man. They still have that. Miss Pac-Man, you go here. You know, it never pays to play in the escape route. Right, you always die when you go there. But you go here and you appear on the other side. You guys remember that? That's kind of what this is. This is still an ellipse, but it's going through infinity. You buy that? Well, that messes around with some of the formulas when you start doing stuff like that. So that's why we get these negative signs. So 10 looks like this. Number 10 looks like this. 18y squared minus 5x squared plus 72y plus 30x minus 63 equals 0. Now, I'm going to group together x's and group together y's. My suggestion is that we group the y's first. And I haven't done that before with you guys, but the reason I'm doing that is because, do you see how it's positive? All right? And then I have, let's see, minus 5x squared, and I have plus 30x, and I'm going to go ahead and push the 63 to the other side. And so now what do we factor out? Well, 18. And I have y squared plus, isn't 18 times 4, 72? I think so. 4y, so that works out nice. And now please, this is why I wanted to show you this. This is different than what you had with the ellipse. What are you going to factor out here? Negative 5, and so you have to think about what goes in the parentheses. It would be x squared, and then what would come next? Minus 6x. Okay? Okay? And so now it comes down to completing the square, blah, blah, blah. Dividing out. I guess we'll do a little more here. Well, I only have 1 minute. Maybe I'll let you guys complete the square, etc., or we'll do it Monday. But with the last minute, what I want to say is this. You guys going to draw your rectangle? Okay, when you go to graph this thing, you're going to draw your rectangle, whatever it looks like. I'll just do this. Or maybe it looks like this. I don't know. You're going to have your asymptotes. It depends if the ellipse would be a fog or a font. I don't know. But let me say this. Where is the hyperbola going to be? Well, because y squareds are positive, this is going to be a solution, and that's going to be a solution, or this and this. I'm not sure what the picture looks like yet. And so this is a hyperbola that goes up and down. Again, because the y squared term was the one that's positive. I don't know what it looks like, but it's something like that. Okay? All right, have a great weekend, you guys.